to solve a quadratic equation. That's what we're going to be working on in this video. So to start you off, to solve a quadratic equation, it's no different than solving a single variable equation, which you're used to doing. You need to find the values for the variable such that when you substitute them into the equation and complete the arithmetic, you will get a true math statement. For example, 2x plus 5 equals 9. By solving for x, we would get 2. So plugging that in, 2 times 2 plus 5 equals 9. This is true, so 2 is the correct value. To solve a quadratic equation, our first step is that we must simplify our equation into the format of ax squared plus bx plus c equals 0. We talked about this being the standard form, and the key on this is going to be the fact that it does need to equal 0. So I've pulled up a single example, a simple one. X squared plus 5x plus 6 equals 0. Now that we have it in the correct format, we are going to factor the left side of this particular equation, and then at the end we'll set each factor equal to 0 to determine the correct value or solution for the variable. So here we have a factored form of x squared plus 5x plus 6. It's x plus 3 times x plus 2, and that's going to equal 0. So I've set them up separately. X plus 3 equals 0. X plus 2 equals 0. And I'm going to simply solve for x. So by subtracting 3 from both sides here, I get x equals negative 3. By subtracting 2 from both sides on this equation, I get x equals negative 2. Now, why do we do this? Why are we coming up with it setting it equal to 0? Well, the 0 property states that if a times b equals 0, it's only going to work if either a or b is 0, such as 2 times 0 is 0. So look how I substituted the numbers in. First, I took the negative 3. So for each x in the equation, I plugged in a negative 3, which means that the first parenthesis became 0, the second parenthesis negative 1, but 0 times negative 1 is 0. Or, if we take the second possible answer, negative 2 plus 3 in the first parenthesis, negative 2 plus 2 in the second parenthesis. The first one becomes 1, the second one simplifies to 0, and 1 times 0 is 0. Now how come we're coming up with two possible solutions? Well, remember, our quadratic has to a power of 2. So that means that we can have up to 2 possible answers for this particular equation. So let's try another sample. First, we need to simplify our equation so it's into the format of ax squared plus bx plus c equals 0. So for my example, I have x squared minus 4x equals negative 4. First thing you'll notice is that it's not equal to 0 like it needs to be. So I have to first use my algebra to get this equal to 0. So I'm going to simply add the 4 from this side over to the other side. And now negative 4 plus 4 equals 0. And now I have x squared minus 4x plus 4 equals 0. So now I can go ahead and factor this side of the equation. And if you remember back from our previous sections, I'm going to put it into two binomials. So I have x times x, and 2 times 2 equals 4, and the 2x and the 2x added in the middle is going to give me 4. And they both have to be minus to get a positive 4, negative 2 times negative 2, but to get to negative 4x in the middle, the inside and outside terms had to be negative 2x. So that's that step. Now once it's been factored, we still have this side equal to 0. So now what we're going to do is we're going to actually take what we've done, which is we have x minus 2 times x minus 2 equals 0. We're going to set each of those factors equal to 0. Now you'll notice in this particular example, the factors were the same. That means that technically I'm only going to come out with one particular answer. So here I'm going to add 2 to both sides, and my answer is going to be 2. Now we did say with a quadratic, because the exponent's 2, we could have up to 2 possible answers. In this particular case, it just so happens that by using factoring, the only answer I'm going to get is 2. And again, if I want to quickly check that, I just substitute that in. So I take the x and replace it with 2, so 2 minus 2. Put the x in the second one, 2 minus 2 equals 0, and that is correct because 0 times 0 equals 0.